Um, so in this video, we're going to be practicing how to determine when similar figures, or if figures are similar. So I have a set of triangles here. I want to know if they're similar triangles. They certainly look similar, but I can't know for sure until I test their sides to see if they're proportional. All right, so I'm going to set up a proportion to solve this. I'm going to start with, I think I'm going to do the first side. I'm going to do the small triangle and compare it to the large triangle. And set up my boxes this way. I'm going to pick a side on the small triangle. 3 inches, it corresponds to 12 on the large triangle. Okay, and I'm going to go back to my small triangle and pick a side. It's corresponding to the 14 on the larger triangle. So I've set up my proportion. If their cross products are equal, then this is proportional. I could also try to find a unit rate, or I could try to see if I could figure out something times 3 that equals 4. But it looks like in this case it's going to be easier just to multiply. So I need to know if 3 times 14 is the same thing as 4 times 12. All right, so if I multiply 14 times 3, I get 42. And if I multiply 12 times 4, I get 48. So these are not the same. So these triangles are not similar. All right, if I move on to number 2, I'm going to start the same way. So if I do, this time I'm going to do the short side to the long side, just to show you that there's lots of ways to set up a proportion. So in the first rectangle, the short side was 4 and the long side was 15. So short. And on this second rectangle, the short side is 8 and the long side is 30. I just kind of like to identify those with boxes and circles. All right, so this is a 3, sorry. To figure this out, I'm going to, again, so I could do cross products. Certainly that works. But in this case, I know that 4 times 2 equals 8. And I can see that 15 also times 2 would equal 30. So since these are both scaling the same, these are going to be similar. But if you want to practice cross products, you could also do it this way. Is 4 times 30 equal to 8 times 15? Well, 30 times 4 is 120. And 15 times 8 is also 120. So yeah, these are similar. All right, number 3, I'm going to do, I think, short to long again. Yep, right here. Okay, so my short sides are 4 centimeters and 6 centimeters. And my long sides are 6 centimeters and 9 centimeters. All right, and then I'm going to cross multiply. 4 times 9 and 6 times 6. And I know that these are both equal to 36. Since these are equal, then these are similar. All right, if I keep going, number 4, I'm going to again, I like short to long, so that's what I'm going to keep doing. So the short side on the first triangle is 8, and the long side is 10. And then on the second triangle, the short side is 9.6, and the long side is 12. It's important to keep the sides together. So if I'm going to do short to long, I need to make sure I do it with the same triangle and the same ratio. All right, and so when I multiply, 8 times 12, I get 96. When I multiply 10 times 9.6, start with a 0, 0, 9. I get 960, but don't forget about this decimal here, so I need to move that over 1 place because there's 1 here. So these are both actually equal to 96. So yes, these are similar. All right, and in problem 5, do short to long. So in the first rectangle, the short side is 2, and the long side is 5. The second rectangle, the short side is 6, and the long side is 14. Okay, notice that this rectangle, they had sort of moved it like they had done in a couple of these other problems, but if I'm doing short to long, then that's not going to confuse me. All right, now I'm going to test my cross products. And 6 times 5 and 2 times 14. I know that 6 times 5 is 30. 2 times 14 is 28. These are not equal, so these are not similar. Okay, and I could have seen that this way also. I know that 2 times 3 is 6. I know that 5 times 3 is not 14. So that would have been another way to test those to see if they were similar. All right, and then the last one, I am going to, these are trapezoids. Okay, so I'm going to set up a proportion. Let's do about the big one to the small one, just to be different. All right, so I'm going to pick a side on the big trapezoid, and then I'm going to start with 6. And I can see that they've rotated this trapezoid. So this side on the small triangle that corresponds to the 6 would be a 2. And then I'm going to pick a different side on the big triangle, or big trapezoid, sorry, 9. Kind of that slanted side there. And so on the small triangle, that would have been the 3. All right, so if I cross multiply 6 times 3, and 2 times 9, I'm going to get 18 for both of these. So it looks to me like these are going to be similar. But since they gave me this extra side, just to double check, I'm going to go ahead and do it again. And this time, I'm going to use these two. So on the big triangle, this bottom side is a 12. I'm sorry, these are not triangles, these are trapezoids. On the big trapezoid, the bottom side is 12. And then when I rotate it, the longer side there is 4. And then I'm going to pick another side to compare that to. So I'm just going to use the 9 here again for the big one. So that corresponds to the 3 here on the small one. And then test my cross products. And you can see 4 times 9 and 3 times 12 are going to be equal as well. So it should work for any sides. If their sides are corresponding and have similar cross products, then you know you have similar figures. Okay, oops, sorry. All right, thanks.